Yeah, so we start now.
Yes, sir, we shall start.
Yeah. So today, we are going to see that IoT with Raspberry Pi. So what is the IoT and state of the art of IoT and challenges and limitation of IoT and Azure IoT with Raspberry Pi. So we are going to cover this content today. And so Internet of Things is nothing but it is, so we can connect remote device to the internet, and we can control remote place device. So like it can communicate anywhere. So we can use it for aeroplanes, truckings, and satellite, and our home automation also we can do. So we can control our refrigerator and TV, watches, etc. The Internet of Things also is called the Internet of Object. So refer to wireless network between the object. Usually the network will be wireless and self-configuring, such as household appliances. So by embedding the software range, mobile transceivers into a wide array of additional gadgets and everyday items, enabling new forms of communication between the people and things, and between the things themselves. The term Internet of Things has come to describe a number of technologies and research disciplines that enable the Internet of reach out into the real world of physical objects. The things having the identities and virtual personalities operating in the smart spaces using the intelligent interfaces to connect and communicate within the social environment and user context. So we can, as I said, we can communicate many devices. Like locally, we can do that. Many projects like so wireless communication, like Bluetooth. Between the Bluetooth, we can communicate many devices. For example, our mobile phone also, and Zigbee and Z-Wave also. And this is communicating over the internet also. So from the, for example, we can take some device. So we can have some watches or wristband device. We can have it. This device we can wear in our hand, and we can, if it is having any button, press something kind of input part. So we can press the button. Immediately, it will communicate to the next near Bluetooth device. From the Bluetooth device, it is as a central device, and the device is a central device. From that, we can communicate to the internet. So like that, from any time, any place, we can connect for anyone. We will know how connectivity for anything. So anything we can connect it, right? So it may be between PCs or human to human. Uh, not using a PC, and human to things using the generic equipment, things to things also we can communicate, and we can communicate any place. So indoors, outdoors, like that, and anytime we can communicate, day, night, and outdoors, indoors, like that. So IoT perspective, like IoT acceleration, so this is a central part of device. So we can take Raspberry Pi as a central part of device. So it is like some microcontroller having inbuilt ADC, something like that, or externally we can connect with that sensors like temperature sensors or humidity sensors, like that. We can have it. That control does not have the internet features, so we can communicate to the internet through the some communication we can do, like LAN communications or Bluetooth communications or UART communications, like that. So we can do it, and we can communicate to the Raspberry Pi device. From the Raspberry device also we can communicate to the internet, and from the internet also we can communicate to the cloud device. For example, so microcontroller, we can communicate to the IoT acceleration part, that means Raspberry Pi device, and sensor also we can communicate to the Raspberry Pi, and application development, some application also we can have it, and through that also, for example, we can have a mobile app. That mobile will communicate to the Raspberry Pi device through the Bluetooth, and some wireless connectivity also fine. So like Wi-Fi, we can take it and we can communicate to the next device and communicate to the Raspberry Pi device. So finally, the data will go to the cloud device. So cloud, it is like a database. It will collect all the information from the device. And why Internet of Things? Dynamic control of industries and daily life, resource efficiency and energy conservation, improve the resource utilization ratio and better relationship between the human and nature, pollution and disaster avoidance, we can do it, forming an intellectual entity by integrating human society and physical system, and universal transport and internet working, accessibility and usability, and act as a technologies integrated like that. And so the IoT value chains like the radios, sensors, microcontrollers, and many application models and platform softwares, application softwares, and device and airtime and services. The radios. So radios means it is emitting the radios signals, right? Chips that provide the connectivity based on the various radio protocols, like UART communication. Also, we can take it and we can send the data through the wireless through the radio channel. And sensor. So we can get the data from the sensor. For example, we can take some temperature sensor. We will measure the temperature, and periodically we can send it to the Raspberry Pi from the microcontroller, or directly we can connect the sensor to the Raspberry Pi. From that, we can get the temperature of the particular place, and we can send it to the Raspberry Pi device. Then we can go to the cloud device. It is a central part of DB. And microcontrollers like a processor or storage that allow the low cost intelligence on chip. So microcontroller is the cheapest one, so we can use it in many places to controlling the real world. And models. So models like combines of radios and sensor and microcontrollers in a single package. And platform software that activate, monitors, and analyze the device network. And application software presents information in usable or analyzable format for end user. And device integrate the models with the application software into a usable form factor. Airtime, use of licensed or unlicensed spectrum for communications. So we can get the some range of transmission and receiving signals. We don't need to get any license for that. Some around 800 meters we can transmit and receive without getting any license. And service, deploying and managing supporting of IoT solutions. We can deploy it and manage it. So this IoT device. So vertical market solutions. So we can have the IoT device in many fields like biosensor, technical people and equipment in the public place. We can have it, and so for the virtual environment also we can use it. And transportation vehicle, in that also we can use it. We can control the many devices remotely through the IoT. And home automation also we can use it. We can remotely we can switch on and switch off the light, fridge, and TV, etc. We can control it remotely. And some regional office also they are using. The looming of opportunity, Internet of Things. So in the consumer, like smart home control, lighting, security, comfort, optimizing the energy use, maintenance. For this purpose, they are using. And in the retail, product tracking like inventory control and focused marketing. So if we send any product, so we can remotely monitor it through that IoT application. Where the package is available, like that, where it is moving, like that, we can monitor it and tracking it. In the medical device field also, we can use that IoT product, like wearable device. So like our watch or wristband device, we can have it. For the elder people also, they are not able to come and walk, then they that time they can have some wristband devices they can wear as a watch, and they can press a button on that wristband device. Then immediately it will trigger the alarm and to the nearest IoT device. That IoT device will can communicate to the cloud device. From the cloud, it will we can have the applications, and we can transmit the data to the mobile. It's like that we can do it. And we are having many areas to implement the device, and telehealth service also we can do it. So periodically we can have a call, like we can set that alarm and it will get that appointment. Like that we can set a call and we can intimate it. In the military also they are using for the resource allocation and threat analysis, troop monitoring and all. In that industrial, also they are using like smart meters and warehouse sensing and manufacturing control or climate control, like that. In the automotive domain also they are using like parking and traffic flow, for monitoring the traffic flow and anti-theft locations, like that. And in the environment also they are using like spaces tracking and the weather predictions and resource management. In the agriculture also they are using crop management and soil analysis. For this purpose they are using the IoT. For example, we can take a house and we can control the lights, speakers, windows, shadows, laptops, TVs, tablets, everything we can control it. Uh, and in shopping also we are using, like when shopping in the market, the goods will introduce themselves. When entering in the door, the scanners will identify the tags on her clothing. So nowadays we are using the ID card. So from that also, the ID card also can communicate to the IoT device. From the IoT, we can monitor and control remotely. When paying for goods, the microchip of the credit card will communicate with the checkout reader. And when moving the goods, the reader will tell staff to put a new one. And in the healthcare also we discussed, we can use it like this. And so we can communicate in the through the LAN also we can communicate, and through the WAN also we can communicate. So in the local network also we can communicate many device. For the patient also we can communicate. And the transportation field also they are using this to monitor and control the product, as well as in the vehicle also we can control remotely. So like that, so we can communicate to the RFID, this RF signals we can through RF signal also can communicate to the internet. And sensor also can communicate, and smart technologies and nanotechnologies also can communicate to the internet. So RFID, like to identify the track and the data of the things, we can use it. And sensor to collect and we can collect and process the data to detect the changes in the physical status of the things. And smart technology, like to enhance the power of the network by developing the process capabilities to different part of the network. And in the nanotechnology also can use it, like a small piece of component we can take it that has the ability to connect to the internet. And sensor technologies are the magic of the IoT. The ability to detect the changes in the physical status of things is essential for recording and changes in the environment. So wireless sensor technology is playing the role in the bridging the gap between the physical and virtual world, and enabling things to respond to the changes in their physical environment. Sensor collect the data from the environment and generating information and raising the awareness of the content. Sensor market includes like micro electromechanical systems based on the sensor, optical sensor, or ambient light sensor, and gesture sensor, and proximity sensor, touch sensor, fingerprint sensor, etc. Total challenge of IoT, like technical standardizing in the most areas are still remain fragment. So managing and forecasting rapid innovation in a challenge for governments, and privacy and security, absence of governance, and vulnerability to internet attack. These are the challenges in the IoT. How to convincing the user to the IoT technology will protect their data and privacy and tracking it. So potential solutions like legal and regulatory use it, and the technical control we can do it, and social ethics like market self regulations also we can use it. Then challenge of IoT, like solution of the main challenges is education and information central aspect for the success of upcoming IoT, capacity building programs and breadth and depth engines and strategic communication plan and opportunity based threat of IoT. Solution of the main challenges legislation, like two approaches. One is the real law and cyber law. Lack of legal instruments like privacy, intellectual property rights and security, and data protection and cybercrime. Then the future of IoT, like we can implement in the many fields in this traffic issue, and in the production, some industrial productions also we can use it, and logistics also we can use it, and the retailing also use it, and resource and power control we can use it. There are three core sectors for the IoT, that is enterprises, home, and government. So now we need to buy anything in the we no need to go to the online for any time for anything. Now we have IoT with us. So with IoT, you no need to go to the online because your environment is already there serving you. So if you don't need to be online, then IoT will eliminate the internet online. And we are seeing that going to see that Azure IoT with Raspberry Pi publish the temperature and humidity sensor data to Azure IoT Hub using Python. So how we are using the IoT for transmitting data from the Raspberry Pi to cloud, and we can receive those status also in our mobile app. So for that, what are the components required for that? So in the hardware sides, we can have the Raspberry Pi 3B and micro SD card 16 GB, and this is the THT sensor is humidity sensor, so we can measure the humidity and all. And micro USB 5-volt cables, we can use it for enabling the power supply in the Raspberry Pi device. And also we can use that any OS like debian OS or Windows, or we can use that we can install the OS in the Raspberry Pi. It will boot up. And what are the softwares required for IoT device, like for controlling the remote devices? Software, like we can do it in many ways. For controlling the remote device, we can use a Python script, and we can use the C application also. So in the C side, we can use that REST API. That is REST call is there. It is the library. It is the core library for the IoT communications, and also we can do it in the Python script also. So this software you can install in the Raspberry Pi device. So Python, and if you are using the sensor, for that we have library THP library for Raspberry Pi. We can install it, and some dependent packages also we need to install it for the Azure communications. So Azure communications, like so we can receive all the data from the device. So that device could be communicated to the Raspberry device, and from the Raspberry device we will collect the data and hold it. So we need to post those data into the cloud. For that we are using the Azure IoT. So this is my Microsoft Azure IoT. So it has some dependent packages, library also is available, and we need to download and install it, like Azure IoT device, and Azure IoT Hub, and Azure IoT Hub Service Client, and Azure IoT Hub Device Clients. Those packages, those are the dependencies we need to install in the Raspberry Pi. And this is the schematic diagram. So how to connect the sensor to the Raspberry Pi. So it has the power supply. So red and black is for used for power supply, and green and yellow is used for the data signals. And we need to use 100K 100 ohm resistor to sensors. And the connection details in the Raspberry Pi with the sensor. Sensor has 3-pin connections. As I said, VCC, we need to connect with the Raspberry Pi, and ground need to communicate to the Raspberry Pi ground, and the sensor data output we need to connect to the GPIO 4th pin of the Raspberry Pi. And for creating the Azure settings also, we can do it. Nowadays we are getting the free trial cloud, we can get it. So for that, we need to go to the Azure homepage, and we need to create a resource for that, and we need to search for the IoT Hub. Like that, you can search in that, and after that, we need to select that marketplace field and select IoT Hub from the search result, and select to create. So so we can set that IoT Hub in the Microsoft Azure, and we need to create it. It has some authentication key and encryption key, and those keys we need to copy from that Azure to our Raspberry Pi device. Then based on that, it will handshake it, then it will acknowledge it, and we can send it to the Raspberry Pi device to cloud. So from the cloud also, we can send the data to the Raspberry Pi. So for that, we are using cloud to message communication. So we can do it, and we can do it device to cloud message also, we can do it. And those messages we can receive in the Azure side. Azure side, like we are having the uh, uh, that is the command line we can have it. So from that we can set some set of commands, and we can send it to the device, and the vice versa also we can do it. So uh, and in the reverse side also we can do it. And from the Raspberry Pi DS we are collecting the data, and we are sending to the cloud device. So for that, you need to install some Microsoft Azure IoT Hub in your PC, or in the Linux machine also we can do it, or your laptop also we can do it, and we can transmit the data and receive the data over there. And from the DB, that is the cloud, we can take the data, and we can communicate to the mobile. So there also we can create some applications for fetching the data from the cloud, and we can store, we can validate the data. So like for what purpose this data is coming, like that we can validate it, and finally we can send it to our mobile also through the HTTPS protocols, like that. So we can use it, or MQTT also we can use it. So that is for cloud to mobile communication. That is another part. So like that, from our mobile also we can monitor it all. And in the medical field also they are using, like people can wear the wristband device. This wristband device, it will communicate. It will communicate to the Raspberry Pi device. So whenever you are pressing the button on the wristband device, immediately it will send the data, like alarm ID and where we are locating, like position also, so we can calculate it. The position data also, so where we are placing. So for example, you can take uh, Google, yeah, like that. So you are finding the locations where you are, like that. So for like that, we have another field for that, like uh, position tracking and monitoring for the indoors purpose. Like so, we cannot use that Google map to track the inside of the buildings. So for that, we need to use that positioning map. We need to use it actually. From that, we can measure that where we are locating, like that, in the building, like that also we can use it. And from that, we can identify the position of the patients. We can identify, and we can if any emergency is there for that particular patient, they can also press the button. So no need to go and inform to the doctor, or no need to call them. Just press the button. What it will do, it will calculate the positions where we are, like that. So we have a set of node for that. That means node is another NRF device we are having. That is for calculating the positions, and we are using the Bluetooth communication for that. So to the near node and Raspberry Pi device, that is the gateway, central gateway. So we can communicate the nearest field. It will transfer. This node will transmit the data from the wristband device. It will collect the data from the wristband device and transmit to the nearest node or nearest gateway device. Like that, it will collect the data, and it will transmit to the gateway side. From the gateway, it will go to the cloud device. From the cloud, it will transmit to the doctor. So immediately they will get alarm for that, and they will look into the app, and they will come to know so where this patient is there. And like that, they can get all the information. Based on that, the doctor will come and arrive, and he will check it. And also we can use a sensor also, we can use it for the moving object. So suppose if a patient is lying down from the bed, so motion sensor will detect that he is falling down. So immediately, no need to press any button also. Immediately, it will trigger the alarm, and it will send the data to the central device, like a Raspberry Pi. It is a central device, so we can tell as a gateway side also. From the gateway side, it will communicate to the cloud device, and the cloud, from the cloud, it will immediately will go to the mobile app. So doctor finally will come to the particular patient rooms, and immediately he will give the treatment. So if any urgent is there, like that. So like that, we are using in the medical field actually. And so so we have uh, we can do some simple IoT communications using the Raspberry Pi. For example, we can take the humidity sensor. Just you can also do it, and you need to connect the hardware, and you need to collect the temperature data and humidity data, and you need to you can also check it. It's a trial version, like a trial version cloud also we can use it, and you can experiment it. For that, we have some set of library. You can use it for that. Um, yeah. So currently, we are also doing the same kind of things, and it will be released in the next year. So you can also see it.
Sir, excuse me, sir.
Yeah, just a matter. I'm showing on demos like how we can
Sure,
communicate.
sir. Sure, sir.
Yeah. So we can connect the Raspberry device with the sensor, and this sensor having the power supply and data port, and we can communicate to the Raspberry Pi from that. So we can use that Wi-Fi. So Wi-Fi card also we can use it from the Wi-Fi. Also we can connect to the internet. From the internet, we can transmit the data to the cloud, and from the cloud we can do whatever we want. Like if you want to transmit any data to mobile app, we can do it, or within the application we can decide. So whatever we want, we can do with that. Here it is a simple demo. So like so if you connect some sensor like this, it will communicate to the Raspberry Pi. From the Raspberry Pi, it will send it to the cloud. So like that, it is a simple uh, demo. It is simple demo. So how we can do it and how we can communicate to the real world from the Raspberry device through the IoT. It is a Python script, so we can use it in the uh, Raspberry Pi device. So we can use any OS for that, and like our so we can connect our monitor also in the Raspberry Pi device, and a keyboard, mouse also we can connect to the Raspberry Pi device. Then we need to execute that Python script. So after that, it will receive in the cloud. So we have received here, like that we can do it. Yeah. So any questions?
Sir, there is a question in chat box.
Yeah.
Please, sir.
Yeah.
Sir, shall we ask for queries, sir? Sir, sir, one more question. So, respected professors, kindly raise queries if you have. Please unmute yourself and then ask queries, or else you can use the chat box to raise your queries. Respected participants, feedback link has been posted in the chat box. Kindly fill your valuable feedback. Requesting all to submit the feedback form. Sir, shall we wind up the session, sir?
Yeah, sure. Thanks everyone.
Sir, on behalf of GRG Polytechnic College and Instrumentation Control Engineering Department, we felt heartfelt gratitude for accepting our invitation and being a speaker for this program, sir. Despite of your busy schedule, you have given your valuable time to us and you have shared your expertise knowledge. The demonstration and the video footage was quite good and the session was quite fruitful, sir. Thank you.
Thank you.
Kindly support us in future programs, sir.
Okay.
Dear participants, kindly fill your feedback. You can also raise your queries through feedback, which shall be shared with our sir later on. So kindly share your PowerPoint, sir. Kindly revert back in the same email ID which we have sent you. Kindly send your PowerPoint presentation.
Yeah.
Thank you.
Yeah.
Thank you, sir. So I request all the participants to resume back to the session 3 by 1:45 p.m. today. Thank you.
Excuse me, sir.
Yes, sir. Please, sir.
Sir, shall we leave, sir?
Yeah. Yes, sir. Thank you, sir. Thank you, sir.
Thank you.